now that we have a complete waveform for IL with the average value, the height of the ripple, and the maximum value with the minimum value, we can use this information to derive the waveform for other currents. Okay, so the first one, we'll use that to find the switch current IS. We can use this information to find the IS. Okay, so first we need IS peak and also IS min. So in order for us to have this, we are going to need the waveform for the IS. Okay, so previously when we did the uh, analysis for this buck converter, we knew that during switch on, okay, on for the switch, IS is equal to IL, and then during off, there are no the switch is open. Okay, we have an open circuit, so there is no current going through the switch, so IS is equivalent to 0. Okay, so from here, for the waveform, okay, we are going to divide during on and during off. Okay, so during on, IS is equal to IL. Okay, IS equal to IL, so we can copy the waveform from here. Okay, during the on only. Okay. Okay, so during the on, we have IL as a positive slope, and then during off, IS is equivalent to 0. So from there, during the off cycle, we'll have it as 0. And then when you turn it on again, you will have it the same to IL. And then we return to 0 again when the switch is off. Okay, so this waveform over here, this slope is actually copied from here. So when we copy it from here, we can also copy the maximum value 16 ampere and also the minimum value 8 ampere over here. Okay, so here this one will be 16 and this here will be 8. So here we have this as IS. Okay, and then this is T. Okay, so here we can read from here that IS peak is the same to the peak value of IL, which is 16 ampere. Now that we have the waveform, we can also find the uh, mean value for the IS. So the mean value we can obtain that by calculating the area below the graph. So here, I'm going to divide this into area A and then area B. Okay, so IS mean is equivalent to area A plus area B. So for that we are going to need this width over here, so that will be D. Okay, so that's all we need. Okay, so here this is equivalent to 8 multiplied with D plus half, because we have a triangle over there. Okay, so finally we got this as 6 ampere. For the fourth one, the inductance of L we are going to use this equation here. Okay, so I'm going to write it down. I am E naught T D L. Okay, so we need to use this equation over here to find the inductance of the inductor, of course. Okay, so here as we should know, T is equivalent to 1 over F. So the frequency is given as frequency is 50 kilohertz. Okay, D is the duty cycle. And then, okay, of course, V naught is the output voltage. Okay, so here we already found beforehand that inductor ripple current is 8 ampere, so we can use that information here. So 8 is okay, V naught is 12. Okay, then this will be 1 over 50k. Okay, and then D is half, 0.5. And then from there, L is equivalent to microhenry. Okay, so for a buck converter with VS 24 volt and V naught output voltage as 12 volt with output current as 12 ampere, and given that the frequency of the switch is 50 kilohertz, we need to put the inductor as 15 millihenry.